Hi students, this is Sir Feds. Welcome to the session on solving physics problems. So in this video, I'll be showing to you how to solve problems on basic electrostatics, particularly problems on electric forces and electric fields. So without much further ado, let's start with our first problem. So for our first problem, we have the problem from the University Physics 15th edition by Young and Friedman, and this can be found on page 711, exercise number 21.39. So the problem is that you have 2-point charges, Q1 which is equal to negative 6.25 nanocoulomb and Q sub 2 which is equal to negative 12.5 nanocoulomb are separated by 25 centimeter. So the questions are, you are to find the magnitude and direction of the electric force that each charge exerts on the other charge. Then for letter B, find the net electric field these charges produce at point P as shown in the figure. And then letter C is that what would be the magnitude and direction of the electric force this combination of charges would produce at point P. So by the way, this problem has been modified from the original question in the book, since in the book, only the questions letter B and letter C is the required. So I added the first question, which is find the magnitude and direction of the electric force that each charge exerts on each other. So let's answer individually, or let's answer by parts the problem. So let us first answer letter A, and we have the given in this problem, which are two charges. And you have Q sub 1 which is equal to negative 6.25 nanocoulomb, and that is equal to negative 6.25 times 10 to the negative 9 coulomb. And on the other hand, you have Q2 which is negative 12.5 nanocoulomb which is also negative 12.5 times 10 to the negative 9 coulomb. So as I've said, for letter A, the required for letter A is that you are to find the magnitude and direction of electric force that each charge exerts on the other. So since na may interaction ang imong Q sub 1 and Q sub 2, meaning to say si Q1 nag-exert og force kang Q sub 2, and on the other hand, in the same way, Q2 also exerts on Q1. So, meaning to say, ang atong ipangita karon sa problem is ang F1 on 2 and you have F2 on 1. So, remember that forces are vector quantity, meaning to say they have magnitude and direction. Now, the interaction between the two charges Q1 and Q2 is summarized by the Coulomb's law. So, and according to Coulomb's law, you have the equation now that F is equal to, or the charge or the force that each charge exert on each other is given with the equation K Q1 Q sub 2 over R squared R hat. So take note that here in the equation, the magnitude is given by the K Q1 Q2 over R squared, and you have here the unit vector R hat, which will depend on the direction of the force that each charge exerts on each other. So if we try to draw the problem or try to visualize the problem here, as you can see, the two charges are separated by 25 centimeter, and Q1 is on the left of Q2 and Q2 is also on the right of Q1. So as you can see, we can also assume that the line which these two charges lie will be the x-axis. So if we try to draw the problem here, this is our x-axis, and then you have our first charge. This is our charge 1, Q1, and then you have here another charge which is Q2. So this is also negative. And remember that the distance between the two charges is equal to 25 centimeter. So this is 25 cm. Now, since these two charges are negative, that means say when they interact, there will be a repulsive force between them. So meaning to say, if we try to draw the direction of the forces acting on Q1 and acting on Q2, it would be that you have here for Q1, the force given by Q2 on Q1 would be in this direction. So repulsive man. So meaning to say, mo repel ang duha ka charge. So that means to say, you have the force here which is going in that direction. And this now, since ang naka-experience ani nga charge is si Q1, that means to say, ang naghatag ani nga force is si Q2. So we name this as our F2 on 1. And similarly, since Q2 also experienced force exerted by Q1, meaning to say, mag-repel gyapon si Q2 tungod kang Q1, then the direction of the force would be in the other nga direction. So as you can see, the forces are repulsive. And in this case, si Q1 ang panaghatag og force padulong kang Q2. So we name this as F1 on 2. So from this palang daan, or in the illustration palang daan, we can now see, or we can now obtain the direction of each forces. So we can say that F2 on 1 would be on the negative X, while ang F1 on 2 would be on the positive X, and that would be denoted by the negative J hat for F2 on 1 and the negative I hat for F2 on 1 and the positive I hat for F1 on 2. So muna ni ang ilang corresponding na direction. And on the other hand, the term here nga KQ1 Q2 over R squared denote the magnitude of the electric force or the Coulombic force. So from this equation, if we try to obtain the magnitude that each charge exerts on each other, that would then be simply F is equal to KQ1 Q2 over R squared. And take note, this K is a proportionality constant given by the value 9.0 times 10 to the 9 Newton meters squared per Coulomb squared. Q1 and Q2 are the amount of the charges rather, and then R is the distance between the two charges, which is 25 centimeter, or simply 0.25 meters. So if we try to plug in the values we have here, so our K would then be equal to our F rather would then be equal to 9.0 times 10 to the 9 Newton meters squared per Coulomb squared times Q1, which is 6.25. So in this case, we can directly magnitude naman ang atong gipangitaan nga case. So we will assume that we will consider the absolute value of the Q1 and Q2. So since magnitude man ang atong gipangita. So for this type for one-dimensional nga problem, or one-dimensional nga problem rather, we can simply omit the signs in the equation, since we can directly obtain the direction by looking at the drawing, or simply obtaining whether in which direction mag-move ang mohang forces. So here we simply have to indicate or plug in the values of Q1 and Q2, which are 6.25 times 10 to the negative 9 Coulomb, and you have 12.5 times 10 to the negative 9 Coulomb all over R squared, which is 25 centimeters or 0.25 meters. So you have 25 meter squared. So from this, the value of the force exerted by each charge would then be equal to the value of each charge the value of the forces that each charge exert on each other would then be equal to F is equal to 1.125 times 10 to the negative 5 Newton. So this is the magnitude of the force that they exert on each other. Now, see what I've said, since dimension ako nga, this is the magnitude of the force that they exert on each other, meaning to say, equal ra ang ilahang forces, since by Newton's third law of motion, that for every action, there's always an equal but opposite reaction. Meaning to say, whatever ang force kung ihatag ni Q1 padulong kang Q2, then that is also the same amount of force kung ihatag ni Q2 padulong kang Q1. So force is a mutual interaction. The electric force is a mutual interaction between two charges. You have Q1 and Q2. So sama sa itong gidrawing ganina, diba, remember that if this is our Q1 and this is our Q2, remember that the forces are already, you have repulsive forces. So here you have going in that direction, and this one is also going in that direction. This one is the F2 on 1, since this is the force exerted by Q2 on Q1, and here you also have F1 on 2, since this is the force exerted by Q1 on Q2. So with this idea nga this is negative X and this is also positive X, then we then have the answers now that our F1 on 2 would now be equal to 1.125 times 10 to the negative 5 Newton, and this is directed I hat, while on the other hand F2 on 1 would be equal to negative X, so you have negative 1.125 times 10 to the negative 5 Newton I hat. So negative I hat ang direction sa isa ka force, kay repulsive man ang duha ka forces. So padulong opposite ang ilahang direction. So this is now the answer for letter A. These are the magnitude and direction of the forces that each charge exert on each other. In number 2, what we have in number 2 is that you are to find the net electric field these charges produce at point P as shown in the figure. So in our figure here, you have here the point P, which is in between Q1 and Q sub 2. And from Q2, it is 10 centimeters to the left, while for Q1, this is simply 25 minus 10, so meaning to say, this is 15 centimeter. So, remember, karon ang naka-difference ani karon nga question sa letter A is that in letter A, we were only looking at the interaction between the two. But in this case, for letter B, we'll try to look how these individual charges affect the nearby nga space nila. So, meaning to say, pangitaon na to ang electric field nga ilang maproduce at any point. But for letter B, not a specific point nga gipangita, which is ang kani point P. So, which is 10 cm to the left of Q2 and 15 cm to the right of Q1. So, for our problem, letter B, you have the question now, which is ang required is the net electric field that these charges produce at point P. So, in this case, since there are two charges involved or mag-produce ang electric field at point P, meaning to say, this is the electric field produced by Q1 at point P, and this is also the electric field produced by Q2 at point P. And for this one, the equation for the electric field is given by E equal to K times Q over R squared R hat. So where R hat, or R rather, is the distance from the source point to the field point. So source point is ang location sa charge, while ang field point is ang location kung aha nimo gitanaw ang effect nga or ang electric aha nimo i-measure ang electric field. So in that case, ang kaning P diri sa atong figure, this is now what we call the field point, and these two here kani diri ug kana, these are the source point rather. So ang R hat sad is a unit vector directed from the source point padulong sa field point. So again, it is from the source point to the field point. So meaning to say, ang Q2 padulong sa left ang imong R hat, ang Q1 is padulong sa right, kay padulong man sa field point ang R hat. So what we'll have to do is to substitute this equation on this equation here. So for our total or net nga electric field produced at that point, we then have K times Q1, so this is Q1, and then R1 squared, R1 hat, and then K Q2 over R2 squared R hot. Okay? So, with this in mind, pwede na ito nimang factor out ang K, and then we have the equation nga K times the quantity Q1 over R1 squared R hot o R1 hot plus Q2 over R2 squared R2 hot. So, sama sa akong giingon kanina, if we try to draw the R unit vector R from each charges, meaning to say if this is our Q1, let's say this is our Q1, and then you have our Q2 here, the R hot or the R hot vector is always from the source point to the field point. So meaning to say, kani siya would be our R1 hot. This is our R2 hot. And then, padulong po dito, gikan na rin padulong dito, this is now our R1 hot. So, the unit vector for R1 and for R2. And take note that kani siya nga distansya, this is now your R1, which is, as I've said, 15. And this one here is your R2, which is 10 centimeter. So, ang buhaton na to karon is that pwede na to i-diretso paghapon o assume diretso sa atong problem unsa ang direction sa electric field kada E1 and E2. So, for example, without thinking about the direction of R1 and R2, kung atong individually tan-awon lang ang contribution sa kada charge, ang Q2, let's say for example ang Q2 at point P, ang iyang ma-produce nga electric field is padulong sa right. Now remember that for a negative nga charge, the electric field is always directed towards the charge. So meaning pasulod sa charge ang imong direction. So in this case, ang Q2 should be ang E sub 2 rather would be on the positive nga direction. So this is the direction of our E sub 2. Okay? And then on the other hand here for the negative nga Q1 from point P, the same naman gikan sa point P, padulong man pud kanina pud atong gitan-aw. So ang electric field tungod ang Q1 at point P. So ang electric field at this point is again inward padulong sa iya. So meaning to say at this point E sub 1 is also in this direction. Kanidre padulong dito ang imong E sub 1. So pwede na to without even using the idea nga ang R hat using the idea nga ang R hat 1 is padulong sa right and ang R hat 2 is padulong sa left. Pwede na to mitan-aw ni nga direction daan ni para ma-determine na to unsa ang atong ibutan diri sa atong equation. So that would then be, if we try now to substitute the value on the equation, okay, so for our E, for the electric field, the total electric field at point P, this is now equal to ang K, which is 9.0 times 10 to the 9 Newton meter squared per Coulomb squared, and then times the whole quantity, which is now ang Q1 over R1 squared R1 hot. So remember that R1 hot or ang E1 naman ni diretso atong gitan-aw. So E1 is to the left, meaning to say you have negative here na sign. So negative na gyapon na siya kung tan-awon nimo, di ba ang R1 hot is padulong sa right. Ang Q1 is negative, so negative times positive, the answer must be negative. So this is Q1, which is now 6.25 times 10 to the negative 9 Coulomb all over ang distance R1, which is 0.15 meter squared. And then plus sa isa, ang E sub 2 is padulong sa right, so as is nagyapon ni nga positive. So ma-positive po na siya kay tungod sa equation, di ba? Sa equation is na kay Q2 R2 hot. Ang Q2 is negative, ang R2 po na to is padulong sa negative, so negative times negative you have positive. So this is 12.5 times 10 to the negative 9 Coulomb over 0.10 meter squared. So, with this one, the value of the net electric field or the combined effect of the electric field at point P due to these two charges would now then be equal to 8,750 Newton per Coulomb, and it is directed I hat. So you have 8,750 Newton per Coulomb I hat. So which means to say, kung tanaw na to ang equation, diba, you have a negative here. The answer sa first term, this is negative. Second term is positive. So obviously, mas dako og effect ning imong 12.5 times 10 to the negative 9 Coulomb, aside sa tungod kay dako siya og charge, but also tungod kay mas closer siya sa field point. So kung balik ko na to tanawon ang equation na ang E is equal to K times Q over R squared R hat, meaning to say, ang imong electric field is directly proportional to Q. So kung magkadako ang Q, magkadako pud ang electric field. But it is also inversely proportional to the R squared. So meaning to say, the more nga magkadako or magkagamay ang value sa R or ang distance between the source point and the field point, ang electric field pud is magkadako. So that is why, kung makita na to, ang combined effect between the two charges is that must dominate ning sa second term. So munang positive ang imuhang answer and he. So that means to say, the total electric field at point P is directed towards the left. So this is now your net electric field. So directed towards the right. So as I've said, this is now the electric field that these charges produce at point P. Okay? So and lastly, for letter C. In letter C, the question was to what would be the magnitude, or to find the magnitude and direction of the electric force that this combination of charges would produce at point would produce on a proton at point P. So here at point P, diba, remember that this is now your Q1 and this is your Q sub 2 and this is the point P. At point P, we will now assume nga naatay ibutang dira nga another charge which is a proton, or ang charge nga proton is atong ibutang diari nga location. So this is plus. So meaning to say, let's say this is our Q sub 3. So Q sub 3 ni siya, but this is equal to the proton. So since ang electric field, ang charge, whether ang electric field sa isa ka charge is present man na siya whether na-charge sa imong field point or wala. So karon in the presence nga ang katong field point nato, ibutang na nato og kanang another charge, meaning to say katong charge nga imong ibutang sa field point, maka-experience ko siya og electric force tungod sa katong mga charges nga nasa iyang palibot. So for example, si Q3 kay di ba sa previous nga problem ang atong ipangita is ang electric field sa Q1 o sa Q2 at point P. So wala ang naka-difference mo ato sa letter A nga question is ang interaction ng nilang duwa nga atong gitan-aw. Wala ta nang tan-aw sa electric field. Pag abot sa number 3 karon tan-aw na to karon sa effect ani nga electric field if magbutang ta og charge at the point P. So what would happen is that Q2 would exert a force on Q sub 3, and on the same way Q1 would also exert a force on Q sub 3. So which is ang atong gipangita diri sa problem sa letter C is that to find the net force on Q3. So this is what we are looking for, the net force or the magnitude and direction of the net force or electric force on Q sub 3, which is the proton. So since superposition of forces sa mga po natong buhaton diyan kay namatay do ka electric field nga na-produce diyan sa point at point P, meaning to say our F net now on F net would then be equal to the force due to Q1 on Q3, or the force exerted by Q1 on Q3 at point P plus the force exerted by Q2 on Q3 which is located at point P. So, going back on the equation sa katong imuha ato ang Coulomb's force, then this is equal to K Q1 Q3 over R13 squared. This is R13 hot. Okay? And then on the other hand, this is K Q2 Q3 over R2 squared, R23 squared, R23 hot. So, take note nga ang common nila, na common factor ang duha, which is ang kaning K, or aside sa K, but rather ang kanilang Q sub 3. So, kung atong ikuan ang Q sub 3, then we have the equation now that this is now Q sub 3, or ang F net would then be equal to Q sub 3 times the quantity Q1 over, or sorry, this is K Q1 over R13 squared R13 hot plus K Q2 over R23 squared R23 hot. But remember that this term here, kaning KQ over R squared and KQ over R squared are the electric field due to these two charges, Q1 and Q2. And that is, ang R123 is naman ang R123 is kaninga point, R123. And then on the other hand, kaninga point, this is R23, which are the value of the distances nga itong gigamit kanina sa letter B. So meaning to say, kaning total nga equation, or kaning tibok nga equation within the bracket, this is simply our answer in letter B. So, or simply, you have F net, which is now equal to Q sub 3, and this is now E sub 1, and then plus E sub 2. Okay? So, with this in mind, meaning to say, kaning Q E1 plus E2, di ba? Ang E1 plus E2 is already our total electric field. Then, F net on 3 would then be equal to Q sub 3 times the net electric field. And from the previous problem, so if the electric field, net electric field is 8,750 Newton per Coulomb I hat, then this is simply the charge of the Coulomb, or I mean the charge of the proton rather, is 1.602 times 10 to the negative 19 Coulomb times the electric field, the net electric field, which is 8,750 Newton per Coulomb I hat. So, again, here, makita sad nato nga ang answer would be equal to, the answer then, the net force due to these charges at point P, if we place a proton on that point, would then be equal to 1.402 times 10 to the negative 15 Newton. So, this is the net charge. So, since positive man po itong ato ang electric field ganina, and then positive nga itong charge, then the net force would also be positive sa gihapon. So, this is still I hat. So, ma-explain gihapon nato na if we try to draw the problem. So, remember that if this is again your Q1, this is now our Q2, and this is the Q3 at point, this is positive, and you have Q3. Remember, nga if mag-exert of force si Q1 kang Q2, remember, the two are opposite charges. Meaning to say, the interaction would be attractive forces. So, positive charge would be attracted to Q2. So, ang force karon ni 2 padulong kang 3 is on that direction. So, this is now your F1, this is now your F2 on 3. On the other hand, si Q1 ug si Q3 are also opposite ang ilahang charges. Meaning to say nga kani si Q3 would also be attracted on Q1, which is also on that direction. So this would be our F1 on 2. However, as you can see, the same ra gyapon ang makita nato sa equation sa Coulomb's law, nga this is K Q1 Q2 over R squared R hat. The same way, ang Coulomb's force is also directly proportional to the magnitude of the charges here product of the charges, and you have the R squared. So the more nga magkadako ang product sa duha ka charges or the more nga magkagamay ang ilang distances, meaning to say magkadako pud ang imuhang force at that point, which is kung maliko na to between the two Q1 and Q2, mas dako ang Q2, meaning to say mas dako jud siya og effect on the electric force. And then on the other hand, since mas gamay po ang distance nila, meaning to say, mudako gyapon ang electric force nimo kay inversely proportional naman sa R squared ang imuhang electric force. So that is why the net electric force is also towards the right. So the same ang direction sa imuhang electric field. But in the case nga instead nga ang Q3 nato, di ba kanina dire, ang Q3 nato is the proton. So you will notice nga for the case of the Q3 nga equal to the proton, ang imong electric same ang direction sa imong electric field, same ang F ug ang imong electric field og direction. But for the case nga we have, if instead of the proton, we'll assume if ang Q3 is equal to the electron, so since negative charge man gyapon siya, meaning to say mo repel ra gyapon siya, so opposite na pud ang atong makuha nga direction, and that would be negative. So in that case, you have, if Q3 is electron, then opposite ang imuhang F ug ang imuhang electric field in this case. So that is all for number 1. Okay, let's proceed with our problem number 2. And the problem can be found on the 11th edition of College Physics by Survey. And it is on page 523 to 524, problem number 33. So, according to the problem, there are 3 identical charges which has a charge of negative 5.0 microcoulomb or negative 5.00 times 10 to the negative 6 coulomb, lie along a circle of radius 2.0 meter at angles of 30 degrees, 150 degrees, and 270 degrees as shown in the figure. So what is the resultant electric field at the center of the circle? So here, this is now the picture of the problem. So you have a circle of radius 2, and there are 3 charges. Q1 is our Q1, Q2 and Q3, which are equal, and they are located at an equidistant from the center. However, ang nakalahi lang is that ang ilang location, Q1 is at 30 degrees, Q2 is at 150 degrees, and Q3 is at 270 degrees. So, ang gipangita nato karon sa problem is the overall effect of the, or combined effect of the electric field of these charges at the center of the circle or at the origin. So, for this problem, number 2, we are given with the charge Q, which is negative 5.0 microcoulomb or negative 5 times 10, 5.0 times 10 to the negative 6 coulomb, and you have the R. The distances of each charge from the origin or from the center is 2.0 meter. So, if we try to first analyze the problem, so again, this is our Q1, this is now our Q2, this is the point P, and this is the Q sub 3. So, since mo na itong Q1, meaning to say Q1 is at a distance R1, this is now our R1, which is equal to 2 meters, or R2 is this one also, which is also 2 meters, and this one here, R3, is also 2 meters. So the same na silang dulo. So meaning to say, pwede na ito isulat as our R1, R2, and R3. And so with this as our Q1 and Q2 and Q3. So ang required ko ron sa atong problem is that you are to find the net electric field or the total electric field due to these 3 charges at the center of the circle. So, combined effects. So, this is similar to problem letter B of problem number 1, But in this case, tulo naka-charge eh. So, since tulo na naka-charge, so all we have to do is to superimpose the electric fields due to each charges. So, we have E net or net electric field is equal to E sub 1 plus E sub 2 plus E sub 3. So, by equation, the last equation, the equation for the electric field is K times Q over R squared. So, that would then be, you have K Q1 over R1 squared. So, this is the magnitude of the electric field. And then you have the unit vector R1 hat. But R1 hat is not simply I hat or J hat. Kaya as you notice, that is towards in this direction or gikan dere mao ni ang atong R hat. Padulong R hat is from the source to the field point. So this one here now is our R1 hat, which is and it does not lie along either X axis or Y axis. And similarly for E sub 2, this is also K Q2 over R2 squared, and this R2 squared. So later na natin i-equal ng R2. And then for R3, this is also K Q3 over R3 squared R3 hat. So since as I've said, equal naman ang Q1, Q2, and Q3, which is simply Q, and R1, R2, and R3, which is simply R, we can simply factor out K and Q and R squared from the equation. So giving us the final equation, which is now K, a simplified equation na KQ over R squared times R1 hat plus R2 hat plus R3 hat. So all we have to do now is to determine what are this R1 hat, what are this R2 hat, and R3 hat based on this drawing or based on the diagram that we had. So balik ko na to ha. For the first part, okay, before that rather. So remember nga diba this is now the net electric field. So diba, if you can remember sa katong vectors, about vectors, if you have a vector R, so vector R, meaning to say na kay magnitude and direction. So for these cases, ang atong R hat, not to siya corresponding R1 hat, R2 hat, and R3 hat, not to sila corresponding R vector, which is gikan dere sa imong source padulong dito sa field point. So the vector R has magnitude R and direction nga R hat. Ang R magnitude R is 2 meters, and then you have R hat as the direction towards here. But R hat, as I've said, could either be X, I hat, or J hat, or could also be the combined nga I hat and J hat. And also remember nga as vector has also components along the X and XYZ axis. So for the two-dimensional, nakatay X and Y, so meaning to say, pwede na ito i-rewrite as X, I hat plus Y, J hat. Magdepende na lang line whether ang imong X or Y is positive or delay. So for example, kanina rin nasa first quadrant, kanina rin nasa second quadrant, kanina sa along the Y axis. So using this idea of the vector R and then the unit vector R hat, so the equation now for our R hat, or the general equation for the R hat would then be R hat is now equal to R vector over the magnitude R, where R vector is xi hat plus y j hat over R. Okay? So, as I've said, mag-matter na din ang imong x ug y depende sa imong position or sa imong location sa quadrant. But now, since ang ato magi-consider is katong R1 hat and R2 hat and R3 hat from the three charges, so for R1 hat, that would then be, kung tanawin na to, di ba, ang R1, ang ato ang X1, or atong R1 is padulong di adto. So this is now our R1 hat. The R1 hat has components nga negative Y and padulong sa left nga negative X. Meaning to say both X sub 1 and Y sub 1 are negative. So that would then be negative x sub 1 I hat minus y sub 1 j hat all over r sub 1. But r sub 1 is simply r, so this is simply r here. And then for our r sub 2 hat, this is, tanaw na po dato ni, kani siya, q sub 2, ang r2 hat is padulong di adto, kay padulong man sa field point. This is r2 hat, and it has components padulong sa right, which is positive x, and downward, which is negative y. So, meaning, our r2 hat would then be positive x sub 2 I hat minus y sub 2 j hat all over again r2 or simply r. And lastly, for our r sub 3 hat, so ang r sub 3 is simply towards pasaka. Pasaka lang ato ang r sub 3. Meaning to say, wala tayong component along the x. So, which means that this r sub 3 is simply your y component ang mabilin. So, this is simply y sub 3 j hat all over r. So, pasaka ra ang imuhang y sub 3. So, with this equation for r1, r2, and r3, if we plug this into the equation of the simplified equation of the electric field, nga E net electric field is now equal to K Q over R squared. This is R1 hat plus R2 hat plus R3 hat. Then, what would happen is that simplify ang equation. So, remember that R1 hat, R2 hat, and R3 hat has denominator nga R. So, pwede na ito i-factor out ang R, then ma-cube na nindire sa itong equation. This is now K Q over R cube, and this would then be ang mabilin nga terms. So, based on ato niha. So, the have there, ang ato ang terms nga mabilin is you have negative xi, x1, you have negative x1 I hat minus y1 j hat, and then for r2 that would be x2 I hat minus y2 j hat, and then plus y3 j hat. So this is now our equation. So karon ang problema nato is to determine the value of x1, x2, x3, and then you have y1, y2, and y3. So by the way, what ay x3 kay remember upward naman tong sa imuhang point 3 charge 3 ganina. So by reviewing on the ideas of the vectors or components ng vectors, the components are given with the equation nga x equals r cosine theta and y equals r sine theta. But as I've said, since diri na determine naman nato ang mga sign sa imong values sa imong components, then all we have to do is to find the absolute value of the x. So which is the absolute value lang nato ang tuyahang cosine. Kay mo ra man determine whether positive or negative siya. So for our x sub 1, this is now 2.0 meters. Then the absolute value of cosine 20 degrees. This is now equal to 1.73 meters. For x sub 2, this is now 2.0 meters. The absolute value of cosine 150 degrees. And this is also 1.73 meters. So equal ra ang x sub 1 ug x sub 2 kay tungod ang cosine 30 is simply the negative of cosine 150. So ang magnitude nila sa cosine 30 or ang absolute value sa cosine 30 ug cosine 150 is just the same. And we can also see here that nganong wala tay x sub 3 ganina sa equation is that ang x sub 3 which is equal to 2.0 meter, absolute value of cosine 270 would give you 0. So munang 0, wala tay x sub 3 nga component dara. On the other hand, ang y1 which is equal to 2.0 meter, and this is absolute value of sine 30 degrees. This is now equal to 1 meter. Y sub 2 which is equal to 2.0 meter, sine of 150 degrees is also 1 meter. So parehara ang value sa imong sine 30 ug sine 150, which is the same na, so or 0.5. So So times 2, you have 1 meter and 1 meter. And for y3, this is simply 2.0 meter. Absolute value of sine 270 degrees. And this is equal to 0 ang answer. So, with this one, or with this value, pwede na tayo ito i-substitute sa atong equation that is sa atong problem. But all we have, but as you can see here, since equal naman ang ato ang x sub 1 and x sub 2, then, meaning, duharang kabukang nabili na ito din, negative x sub 1 and positive x sub 2. So, meaning to say, kani silang duha, mag-cancel out na sila. This is simply 0 and mas 0 po na siya. Kaya nag-add na ito duha, mas 0. So, wala tayong component along the x-axis. So, kung makita na to, ang mabili na dahil nga equation would be only on the y-axis. Or, ano siya. So, that is now, this is now equal to k cube over r cube. And this is times negative y1, and then you have minus y sub 2, and then plus y sub 3 j hat. But remember, y1 and y2 are 1. So negative 1 minus 1 is negative 2. Plus y3, which is positive 2, then the rest would be equal to 0. So, which means to say that the total electric field at the center of the circle is equal to 0. So, 0 ang combination or 0 ang effect, net effect sa electric field of these three charges at the same na position or at this origin of the circle. Okay, so for our last problem, we have the problem from the 10th edition of the Fundamentals of Physics by Halliday and Resnick. And this is problem number 55. So in the problem, you have 4 identical point charges which has a charge of positive 10.0 microcoulomb are located in the corners of a rectangle. So as shown in the figure. So the dimensions of the rectangle are L, which is 60 meters, centimeters, and width, which is equal to 15 centimeters. So you are now to calculate the magnitude and direction of the net electric force exerted on the charge at the lower left corner by the other 3 charges. So accordingly, natay tulo ka charges here, Q1, Q2, Q3, and Q4. And ang ipangita is to calculate the magnitude and direction of the net electric forces exerted on the charge at the lower left. So kanina sa origin. So we'll try to look for the forces exerted on this charge by the other surrounding charges Q2, Q3, and Q4. So we have the given now, which are again Q, which is equal to positive 10.0 microcoulomb, or 10.0 times 10 to the negative 6 coulomb. And since there are four charges, so we can denote this as also our Q1, Q2, and Q3, and Q4. Equal ra ang upat na charges. And then ang next nga given is that you have the length, which is equal to 60 centimeters or 0.6 meters, and you have the width, which is 15 cm or 0.15 meters. So let's try to analyze first the problem. So accordingly, you have 4 identical electric charges, point charges. So you have positive 1 positive charges. So this is now this illustration. So we'll denote this as our Q1, which is mo na nga itong ipangitaan og ang force exerted on the 3 charges. And then this is our Q2, this is our Q3, and this is our Q sub 4. So as you notice, all the charges given are positive. That means to say nga ang effect ani karon is that these charges will repel with each other. So ang nakakaroon ng interaction is repulsive force. So for example, between Q1 and Q2, ang forces is repulsive. So meaning to say, ang force nga matag ni Q1 padulong kang Q2 is padulong di adto. So nakay force nga padulong di ani nga case kung ang gihatag ni Q1 padulong kang Q2. But ang ato magipangita karon is ang force nga mahatag diri kang Q1. So si Q2 iya pong i-repel si Q1, which is ang direction karon as you can see pareha naman sila og axis, in the same axis on sila. They lie on the same axis, so which means to say ang force given by Q2 on Q1 is directed to the left or negative I. So you have here this force as our F1 or F2, sorry, this is F2 on 1. So which is again negative ang direction. And then if we look at Q3, ang Q3 karon ug ang Q1 also lie on the same nga axis, so vertical axis. So kani sila dire. So the same way, since like a positive man silang duha, meaning to say they will feel a repulsive force. So which is kung si Q1 ang iyang force nga mahatag is i-repel niya si Q3, which is padulong di adto. Nakay force mo padulong di adto. But si Q3 i-repel man pud niya si Q1, meaning to say your F3 on 1 would then be downward. So nakay F3 on 1 which is now downward. So again, this is our Q sub 1. Then if we look at Q4 is not either on X or Y axis, right? So meaning to say, ang line of action sa ilang force is naa ani nga line dire, kani nga line. So in this case, ang Q1 i-repel niya si Q4 padulong di adto, and then si Q4 po iya mo i-repel si Q1 on that direction. So naa kay direction diri sa imong force nga padulong di adto nga case. So this is now F4 on 1. So ang gipangita nato karon sa imong sa atong problem is the combination of this or the combination of these three forces. So what would be the net forces on the lower left nga charge, so Q1. So again, ang required is to find the net force on Q1. So since there are three forces na involved coming from the other three charges, then that would be is superimpose lang, or I mean superposition rather. So you have F net, which is now equal to F2 on 1, then you have F3 on 1 plus F4 on 1. So and the equations for the F2 on 1, F3 on 1, and F4 on 1 are given by the Coulomb's law, so which is Q prime over R squared. So for the case sa ato ang unahon nato ni diri, tanawon nato ang first na equation for for the part sa ato ang F2 on 1. Now sa nato sa F2 on 1. F2 on 1 would be Q1 Q2 over R12, which is simply ang R12, this is simply DL. So R12 squared rather. But since in this case naman ka unit vector, so this is R hat. So remember nga karon ang L ang atong R12 is equal to L. So in this case so makita na pud nato nga ang F2 on 1 is directed towards the negative nga X. Meaning to say, ang atong R hat dire should be already negative I hat. Okay? And then for the F2 or F3 on 1, this is now equal to Q1, Q3, and this is R13 squared, and you have R13 hat. So in this case na po, ang ato ang R13 would be equal to the width. But as you can see, the direction of the F3 on 1 would now be equal to negative Y. So instead of negative R13 hat, we change this with negative Y na dayon. And then lastly, for F4 on 1, for this one, F4 on 1, this is now Q1 Q4 over R14, sorry, this is K Q1 Q4 over R14 squared. So which is ang R14 na to, ang R14 is kani. So which is equal to the square root of L squared plus W squared. Okay, remember, this forms a right triangle. So kani nga part, this is a right triangle. Kani diri nga portion. So mo nang ang imong R14 is L square root of L squared plus W squared. So mo nga tong R14, but our R4 hat, ang kaning R14 hat nato, remember nga ang R is always from the, remember that it's always from the source point padulong sa field point. Kani man ang atong field point karon dire kay mo man ang atong gitagaan sa force, or mo man ang naaman dira ang atong question nga again ang source point is kung aha ang charge kung mahatag sa field or sa force, and then ang field point is kung aha ang charge nga makadawat sa force. So for our R14, take note nga ang imong R14 has components nga negative y and negative x. So in the same way here, this would be ang R14 is ato ni i-change into the equation nga negative L I hat. This is negative L I hat. Sorry, this is negative L I hat minus W J hat over ang R14. So ang R14 again is the square root of L squared plus W squared. So with this equation for F2 on 1, for F3 on 1, and for F4 on 1, we can now proceed on the final equation for the net force. So try to erase this first. So what we have then, sorry. So for again, this is now F2 on 1 plus F3 on 1 plus F4 on 1. So the final, the equation would then be, if ato to i-substitute ang equation sa F sa tanang forces, this would then be equal to this is now K Q. So remember that Q1 and Q2 and Q3 and Q4 are the same. So that would be, pwede na to EQ na lang. So Q1 times Q or Q times Q is simply Q squared. And this is over now L squared. And this is, as I've said, this is now negative I hat. And then plus the second term, you have K Q squared gihapon over kay Q2 o Q3 o Q1, and then this is W squared, and then this is now negative J hat, and then lastly for the K, this is now plus K Q1 and Q4, the same yapon Q squared over the R14. So let's say this is simply R14 squared sa this R14 squared, and then this is times negative L I hat minus W J hat all over R14. So kung atong i-combine like terms ang katong mga naka-I hat, remember sa addition of vectors, dili ta pwede basta-basta maka-add kung dili sila pareha og unit vector. So kinahanglan pareha sa atanaw to natong pareha og unit vectors ang I hat o kaning I hat. So kung makita sa nato sa atong equation, common factor ang K Q squared in all terms. So pwede nato i-factor out, and this becomes K Q squared times the quantity. So for the first term, you have negative I over L squared. So this is now negative 1 over L squared. And then the other one nga na I hat is kani siya. So negative L, so minus L all over R14 squared plus R times R14. So that would be R14 cube. So this is R14 cube, and then this is I hat, and then plus again you have sa J nga term, this is negative j hat over w squared. So that means to say this is also negative 1 over w squared. And then here you have another minus w over the same way r14 cube. r14 cube j hat. Okay. So, na naman tayo value ng tanan, ang ato na lang kinahanglan mahibawaan is what is the value of the r14. So, from the equation, r14 is now equal to the square root of L squared plus W squared. This is equal to the square root of 0.6 meter squared plus 0.15 meter squared. So, the R14 would be 0.618 meters. So, na tayo R14 karon sa tuwang equation. So, from this one, we proceed with the equation. So, from that point, gamito na nato yung final equation nato. So, what we now have then would be kanin siyang equation. So, remember, madili na itong ni-ma-add ng duha ka terms sa kay these are not the same nga unit vectors. So, from that point, F net, the net force would be equal to K, which is 9.0 times 10 to the 9 Newton meters squared per Coulomb squared times Q squared, which is 10 times 10 to the negative 6 Coulomb squared times ang quantity, whole quantity nga negative 1 over 0.6 meters minus 0.6 meters over 0.618 meter cube. This is I hat, and then plus ang term na the other term, which is negative 1 over 0.15 meter minus 0.15 meter all over 0.618 meter cube j hat. So with this one, our answers are now expressed in terms of unit vectors. So the F net or the net force is now given by this equation. F net is equal to the negative 4.78 Newton I hat minus 40.57 Newton j hat. But remember, nga ato pang ipangita karon, ipangita sa number 3 nga problem is the magnitude and direction of the net electric force. So since ang magnitude and direction man ang ipangita nato, so dili ta mo stop ani nga equation. So since force is also a vector quantity, meaning to say kani siya nga term is also our fx, and this term here is our fy. So with the idea of the components of vectors, so pwede na ito masolve ang iyang magnitude and direction using the Pythagorean theorem and the tangent theta nga function. So for the equation for the f or the magnitude of the force, so wala na to ang arrowhead since magnitude naman ito ipangita. F net is equal to the square root of fx squared plus fy squared. And then on the other hand, ang tangent theta would be equal to fy over fx. So with these two equations, the magnitude now of the electric force exerted by the other three charges on the charge on the lower left of the rectangle would now be equal to this one. So F net is now equal to the square root of 4.78 Newton squared plus 40.57 Newton squared. So di ani gitang-tang na nako ang negative kay mas square naman gyapon, so the same na gyapon ang result. So the net force has a magnitude of 40.85 newtons. On the other hand, by solving for the arc tangent or the sine tangent inverse of this equation. So theta would then be equal to tangent inverse of Fy over Fx. So we can also denote, or pwede na itong walaon lang ang negative para ma-determine na ito ang exact jud nga angle. So this is now tangent inverse of 40.57 Newton over 4.78 Newton. And this gives us an answer of 83.28 degrees. However, we must make sure nga kanina po di corresponding nga quadrant. Kaya di naman ito kaingon kung 83.28 degrees, it could either be, remember the answer for the tangent theta or the tangent inverse is only between 0 to 90. And dili na ito makover ang katong from 90 to 360. So, with that, kinahanglan na ito muhibaw ang gihapon o kung unsa nga quadrant ang kaning 83.28 degrees. So, notice that the values for the Fx and Fy are all negative. Meaning to say, this is on quadrant number 3. Or simply, with respect sa atong katong in terms of the north, east, west, and south, then this must be south of west na dayon. So, the final answer, the magnitude and direction of the net force on the lower left na charge, which is now equal to F net is now equal to 40.85 newtons directed at 83.28 degrees south of west. So this is in agreement with our drawing ganina. So kung maka-remember mo sa drawing na akong ipakita ganina, ang katong Q1 nga naa diri, di ba? Kung maka-remember mo, naa siya kanina kay F3 and 1, kanina kay F2 on 1, and this one here is F4 on 1. Mo ni ang yamong combination sa imong forces. So kani pa lang daan sa F4 on 1, this is already directed south of west na direction. And in the same way, negative mo po din F2 on 1 o F3 on 1, then masamot siya nga na-adjust siya ani nga quadrant. So magpabilin siya diri nga quadrant. So again, nag-repel ang muhang mga forces in this case since pareha sila tanan nga positive. Okay, so this ends our discussion for the sample problems on electric forces and electric fields. We'll see you on the next video.